is stock system naming. Stock system naming is actually a type of ionic naming, so it's not really any different than what we've been doing with binary and ternary naming. The main difference here is we actually end up with a case where we have a metal that has multiple oxidation states. So I've shown you manganese. When we say we have multiple oxidation states, manganese actually can have a charge of +2, +3, +4, or +7. So it can actually bond by losing different numbers of electrons. So remember, metals are on the left side of the staircase. I do want you to keep in mind that if we're looking at elements from the right side of the staircase, we are always going to simply use that first charge. So if you're looking at sulfur, you're looking at nitrogen, you're looking at chlorine. This can get a little bit confusing at this point, but anything that is on the right side of the staircase, we are still going to keep just using that first number. There will be a time when we use the other numbers, but it isn't until the end of the year, so don't worry about it yet. It'll be a unit called redox, and it'll be a while before we get there. But we can use different charges from elements on the left side. So you could have a case where you do have to use the +3 charge for manganese. And we have to have a way of communicating that with people. So first things first, you need to know your Roman numerals if you don't already know these. We rarely go up to 10, but you generally need to know up to 6. So make sure you write these down if you're not already really comfortable with them. At least get comfortable with 1 through 6. Those are the ones that we'll use the most. We don't really run into 8, 9, or 10, and 7 is pretty rare. So if we see a stock system name, we see this Roman numeral there, and what that actually tells us is it actually tells us what the metal's charge is. So manganese is Mn. Typically at this point you would go and you would want to look up its oxidation state in the periodic table. For manganese, we're actually not going to do that this time. We're just going to say Mn, and because this is a Roman numeral 3, that actually means manganese has a +3 charge. And this is with bromide, or bromine, if you will. So this is going to be Br, -1. You can bring down this 3. You can bring down this 1. And again, that's a 3 just because it says Roman numeral 3. A lot of people treat this like it's a lot more confusing than it is. The metal's charge is indicated by the Roman numeral. Take it and run. Don't go to the periodic table to look up the metal when you're given a Roman numeral. So now that I've crisscrossed, I get Mn, Br3. This is a 1 to 3 ratio. That's the lowest whole number ratio. The rest of this is regular crisscross. Manganese's charge is +3. We have 3 bromines, -1 each. Their charges indeed equal 0. So Mn, Br3. Cobalt 2 sulfide. There's cobalt. And sulfide is representing sulfur, or S. Cobalt, because we have a +2 charge right here, that's cobalt's charge. We're going to look at the periodic table. Now sulfur, we are going to look at the periodic table. Sulfur's charge is -2. Crisscross, bring down this 2, bring down this 2. This gives us a situation where we actually have what we call canceling. So this is going to become COS. 1 cobalt to 1 sulfur is the lowest whole number ratio. And now we got to check ourselves. Cobalt's charge, remember, according to up here, is +2, and sulfur's is -2, so those do equal out to 0. So pause the video for a minute and try each of these. So for iron oxide, you should have gotten Fe2O3. Fe, this Roman numeral is telling us this is +3, always -2, and then you simply crisscross. Copper has a +2, so this is Cu +2, Cl -1, simply crisscross. Iv means 4, so this is titanium +4, S -2. You do end up reducing on this one, so instead of leaving it as Ti2S4, this actually reduces to TiS2. Molybdenum 3 is Mo +3. Phosphide or phosphorus is -3, so those actually cancel out. I'll give you a mop. And you kind of have these included with table E. So iron, oops, not I. Iron is Fe plus 2, and phosphate, remember, is from that 8 ending, tells us that's from table E. It's PO4 negative 3. So we crisscross these. This 2 comes down here, this 3 comes down here. And we do need to use parentheses to indicate that we have 2 groups of PO4. What can be a little bit harder about this is when you actually see a name, you have to make sure you identify whether or not it means a Roman numeral. I'm sorry, when you're writing a name from a symbol. So right now we have iron, black, sorry. We have iron, and we have sulfur. So we actually have to kind of go back to our formula here for a second. We have to look at the charge of the anion. So our anion is sulfur that's charge is negative 2. So if we have one Fe with a charge of we don't know what, and one S with a charge of negative 2. In order to balance out to 0, we need iron to have a charge of positive 2. So since iron's charge is positive 2, the Roman numeral we are going to use is going to be 2. So we're going to write iron, 2, Sol, and then I'm going to combine this with step 4 for a minute. Instead of sulfur, this is going to be iron 2 sulfide, unless it's from table E. Something from the periodic table, we drop to that "ide" ending. This was a little bit more complicated, so we have nickel and oxygen. We have 3 oxygens here, each with a charge of negative 2. So we looked up that anion charge. We have 2 nickels. So the total negatives coming from our oxygen are negative 6. So we need to have a total of positive 6 coming from our 2 nickels. What this tells me is that each of these nickels has to be plus 3. You kind of can use a reverse crisscross. You have to be careful, though, in case something was reduced. That will screw you up. So it is a good idea to check the anion charge and make sure that that's correct. In this particular example, it does work. So we're going to write nickel. Each of these is plus 3. We don't use the plus 6 to write our Roman numeral. That's just kind of an accounting thing to help us with the charges. But the plus 6 is not the charge of each nickel. We want to tell the charge of each nickel, which is 3. And oxygen becomes oxide. So here are a few for you to try. Pause the video and give them a chance. So I'm just going to break down where these Roman numerals came from. We have 1 nickel with 2 BRs, negative 1, negative 1. Since there's 1 nickel to balance that out, it has to be positive 2, hence nickel 2 bromide. PBF example is extremely similar. So lead, we do not know its charge. If you looked up each of these Fs, they have a charge of negative 1 each, meaning lead has to have a charge of positive 2. Molybdenum we don't know, but oxygen, there are 3 of them. Each of these guys having a charge of negative 2, which means molybdenum, in order to balance that out, actually has to have a charge of positive 6. The reason I put this example in here, so you'll notice that molybdenum's charge is indeed 6 in this name. If you reverse crisscross on this, meaning you just decide to bring this 3 up here, you would write molybdenum 3 oxide. And that's actually not correct, because oxygen's charges are each negative 2. If you brought the 1 up here, you'd be saying oxygen has a negative 1 charge, and it doesn't have a negative 1 charge. So you do need to be cautious with reverse crisscross. It's not something I'd recommend you doing as a habit at this point. Each of the chlorines are negative 1, meaning vanadium has to be positive 3, so vanadium 3 chloride. Just a little wrap up of some general rules from all of our ionic compound naming. In all of our ionic compound naming, our positive ion or our cation or metal, our thing from the left, comes first. Our negative ion always comes second, so that's our nonmetal or our thing from the right. Two capital letters will be binary ionic, and since it's binary, you're going to end in "ide" always. If you have three capital letters, you're automatically looking at table E. Whenever you end in an element, so whether table U is involved, like you have ammonium, ammonium chloride, for example, you still have that "ide" ending because chlorine is from the periodic table. Things from table E never get changed. Don't change their formulas, don't change their charges, their endings, anything like that, and read table E very carefully. Finally, check metals for multiple oxidation states. That will let you know when you use Roman numerals or the stock system.